flag and his group, and we started some new initiatives with the DEC and the National Park Service. But at the time, there wasn't really a lot going on. And the National Park Service actually has funded most of the work that you're going to be hearing about today through their post-Sandy recovery fund. So it was kind of good that we waited a little bit. We're still not at the end of the process by any means. And we're very happy to have the National Park Service, their cooperation and their collaboration on this meeting. And I think Mary Foley's coming down from the Northeast office. We have Charlie Roman came down from Rhode Island, and Chris Solar's supposed to be here. As I said, there's some traffic jams apparently on Nichols Road. So we're very appreciative of their help for this. From the materials we sent out, I think you know that we have several objectives associated with this workshop when we were putting it together. The first one was just to let people know really what was going on, what type of studies and what research projects were going on, to take a look at what was happening with the breach and how it was affecting different resources, especially in the Back Bay area. So that was kind of turned out to be the primary objective. The second objective was to, where possible and where there was information available, to begin presenting that information. And I really want to emphasize this is preliminary data, preliminary information, and kind of the initial findings. We reserve the right to retract, redact, and rescind any statements that are made here today. But we're very fortunate that the researchers who are doing the work agreed to come and talk, even though they have not finalized and tested, all the data and their conclusions. I think it's important for people to have an idea of what's going on and what people are seeing. And the third thing that we really wanted to do was kind of encourage that information sharing and hopefully foster some collaboration and cooperation kind of among the research teams and among the agencies, but also between the research teams and the agencies. I think it would be helpful if the researchers knew kind of what the agencies needed or could use. And I think it's good, of course, for the agencies to get an idea of what's going on and see some of the information, because they have to make decisions even if they don't have all the information they need or they would like. So that was a very important part of this meeting, and we purposely kept the meeting small. We put time in the agenda for a lot of discussion, so I hope that does occur, because I think it's that type of dialogue that's really going to help the managers make the best decision. So with that, if there's a few housekeeping details. One, as I said, we are taping this, so we're going to ask the speakers to wear the microphone, because it has to go through the streaming that they have with the video. Again, we're not going to hold anyone to it. We're planning on posting it to the Sea Grant website after it's been edited and we've looked at it a little bit. The second thing is people that need internet access. This is the Wi-Fi that you should use. I think it asks for your email address or something, but that's the Stony Brook Wi-Fi. We're going to have break materials, and we're going to have lunch. Will be in the back. The bathrooms are in that middle hallway, for those of you that haven't been here, on the far wall. And with that, I would like to get started. I think, can you hand me the report? Some of you old-timers, this is not the first time we talked about this topic. Some of you old-timers, and I see the shining domes out there of a number of people that were involved in this effort. Back in 2000, we actually had a workshop that used modeling results to take a look at what might happen if an inlet occurred, and it happened to be at Old Inlet in Great South Bay, and how that might affect selected resources. And in your packet, you have that report that we came out with in 2001 talking about what those impacts were. And so to kind of give you some background on that and how that integrates with what we're doing today, I'm going to have Henry Bokinjevich. He's a SOMOS professor here and was around long enough to be involved in this and several other meetings. He's going to tell you a little bit about the background and what we're going to be doing today.
I guess, like Jay said, I'm not going to show any data, but the idea is to kind of put a little bit of perspective. When you think of looking at a report done 15 years ago, there may be some old question about why we're doing it. So this is kind of a remembrance of things past, or maybe it's an education for some people who don't really realize that these problems and these concerns have been around for a long time. Way back in 1986, not that old, 1986, if you remember, there was a moratorium on dredging Fire Island Inlet. And as part of that, there was some research done involving modeling of Great Salt Bay, primarily for pollutant transport and salinity changes. So there was an old model done in 1986 by DiLorenzo and Pritchard. It was called a linked node model. You can imagine the computing power wasn't very good. But nevertheless, they were working with these models and trying to forecast changes in dredging activity there. Then we had the nor'easter in December 1992, and a lot of people thought that was going to be a game changer, and in some sense it was. The governor's task force was formed in 1993. They had a rapid series of meetings, and they put out a report of suggestions that both the state and the scientific community should try to implement in preparing for these kinds of disasters and dealing with them. If people who are around then will recognize that a lot of the recommendations are exactly the same as the recommendations that came after Sandy. Later on in that decade, Connolly, a faculty member here, did a model of Great Salt Bay where he put an inlet in Old Inlet in the model and calculated changes. He did not do tides and storm surges, but he had a description of how the circulation in the bay would change, how the salinity in the bay would change. That background material was all then entered into the report that we're dealing with today. So this report has a history of 10 or 15 years in front of it, more than that actually. And the report on the impacts of the barrier island breaches on selected biological resources of Great Salt Bay came from those kinds of previous concerns. As Jay said, we tried to get together people who had been working in the bay, had known what these impacts had been, had known this previous history, and they were trying to then forecast changes. And that's what we're going to deal with, we hope, today. Since then, there have been some other things that happened. The Corps of Engineers, in part of the Fire Island to Montauk reformulation study, supported a great deal of work, modeling work on inlets, breaches, island susceptibility, in part to do the cost-benefit analysis for protecting against these sorts of flooding. So in 2004, they were using a model from the Netherlands called the Delft 3D model. In 2006, our own Bob Wilson and Charlie Flagg did another model where they tried to put in an inlet at Old Inlet artificially in the calculations and look at changes in the tides and storm surges. That was available also. Of course, in 2013, Sandy happened. Immediately after Sandy, since there really was a lack of data coming in initially, a lot of the very old stability analysis, the analytical stability analysis, was trotted out. If those of you who have been following, you'll recognize some of these names. Dean O'Brien, Bob Dean, Nick Krause, Escoffier, Van der Krieg, and a number of other people who had done, over the years, done a number of calculations on inlets and how inlets were stable. It turns out that doesn't get you very far, those sorts of analyses, because of they have to be simplified. Most of them are for single inlet systems, and even though you can argue about the dynamic stability, and the conventional wisdom is that multiple inlet systems are inherently unstable, you couldn't really say anything about the timing. The inlet may be unstable, but it might last a year, it might last 10 years, it might last 100 years. It depends on the magnitude of the disturbances. And almost none of these, although some, didn't include calculations of the stress implied by the longshore transport and the growth of the shoals. So the analytical stability analyses were brought up, looked at, but it was realized that modeling work had to be done in order to predict the fates of this inlet. And to do that, you needed the background information. You needed the hard data. There was one last thing on here on the very bottom. De Wet is a Dutchman who was working at Deltares in the Netherlands, and he did a master's thesis which actually worked on predicting the breach at Old Inlet as it occurred in 2014. So there's some new modeling work going on, and the Park Service has contracted with Deltares to continue that sort of modeling. A lot of these issues were divorced from the biology, and I think one of the reasons for doing the impacts of barrier breaches was to look at going beyond the physics and to get to the biological impacts. So what are we trying to do now? There's a background here. What are we trying to do now? Trying to look at that report that was done in 2001 and revisit a lot of these topics, hopefully in the context of the past history. So we would like to get at, does Superstorm Sandy, does the breach reflect the predictions that were in the 2001 report? Do we still believe those? Have they actually come true, or have they been disproven? We'd like to look at what are the measurable changes. In all of these studies going way back before 1986, getting the measurements, getting the data, the hard information to prove or disprove a hypothesis has always been a serious problem. So we want to look at what have been the really measurable changes, and then need to consider what those changes can be attributed to. It starts to sound a little bit like climate change arguments, but the natural environment, of course, changes all the time, and we want to try to explore whether the connections between the new inlet and the changes that are seen are rigorous enough to be used in future predictions. So that's where we're trying to go. We're going to start with the physical arguments, and I'm going to stop there.
Okay. Any questions for Henry? Okay, well, thank you.